Alright guys, so welcome to my YouTube channel. So for this class today, we're going to be discussing indices. Please, if you're just watching, if this is the first time in my class, my name is Emmanuel, and I would love you to please kindly subscribe to my YouTube channel and also like this video. You have any challenge on what we're going to be doing today, you can mention your challenge on the comment section. Alright, so let's dive into what we have for today. So talking about indices. Now I'll just do a brief introduction on indices. What is indices? Indices is indices is actually a plural form of the word index. So is a plural form of the word index, which mean power. So when we talk about indices, what we mean is the plural form of the word index, which means power. And by power, this is what we mean. We mean x raised to the power of 6. So we have 6 over here is the power, and the x over here is the base. So we have the base to be x and then the power to be 6. So that's basically just a rough in a nutshell what indices mean. So quickly we'll just head over to the laws of indices. Now there are several laws of indices that help us to understand how to solve problems on indices. So we'll just take few of the laws, then we'll launch into questions. So let's look at the first law of indices. The first law is the multiplication law, which is that if we have a base x raised to the power of a times x, another base raised to the power of b. So if we have a number that multiplies like this, the same base that multiplies, the law says that we'll pick one of the base and then we add the powers. So the power is a plus, so the power is a plus b. So we pick the base and we add the power. So that's it basically. Now let's do an example on this. So for example, if we have, say we have 3 raised to the power of 2 times 3 raised to the power of 4. So this is equal to what, based on the law, we just pick one of the base, which is 3, and then we add the power 2 plus 4, and that gives us 3 raised to the power of 6. So this is basically what we're doing over here. Now take note, if we have something like an x raised to the power of 3, x raised to the power of 3 times y raised to the power of 4 or 4. So this is not equals to x raised to the power of 3 plus 4. No, because the base are not the same. So once the base are not the same, we cannot add the power. We only add the power if the base are the same. Alright, so let's move over to the next law. So the next law says, if we have a division, so let's say we have x raised to the power of a divided by x raised to the power of b. So we have a problem like this. So x raised to the power of a divided by x raised to the power of b. So the law, this is a division law. So it states that when we have the same base, we pick one of the base and then we subtract the powers. So for this law over here, all we just need to do based on this, we just pick one of the bases and subtract the powers. It's as simple as that. So let's take example. So if we have 5 raised to the power of 8 divided by 5 raised to the power of 3, this is equal to, so based on the law, pick one of the base, 5 raised to the power of 8 minus 3, and that is equal to 5 raised to the power of 5. We can go ahead to simplify that as well. So but basically this is just what we want to show here. So we're done with this. Let's move on to the next law. Now for the next law, let's talk about the zero law. So if we have x raised to the power of 0, this is equal to 1. So the law says that whatever we have raised to the power of 0 is equal to 1. Whatever number raised to the power of 0 equals 1. So for example, if we have 100 raised to the power of 0 is equal to 1. 1000 raised to the power of 0 equal to 1. So this law says that whatever number raised to the power of 0 equals 1. So that's it for this zero law, just to show us that is as easy as that. Now let's make progress. So the next law we're going to be talking about is number 4. So if we have x raised to the power of minus b, let's say minus b or minus a. So x raised to the power of minus a. Now this is equal to, as a result of this minus sign we have here. Now whenever we have a minus sign as a power, the minus sign as the power there will just be equal to 1 over x raised to the power of a. So that minus sign symbolizes 1 over. So whenever we see a negative sign here as a power, it just symbolizes the inverse. So it means the negative sign there, it means the inverse of x. Whenever we see a negative sign as the power. So if we have x, the inverse of x is 1 over x. If we had 1 over x, the inverse of 1 over x is x. It's as simple as that, just the inverse. So for example, if we have x raised to the power of minus 2. So this is equal to 1 over x raised to the power of 2. And so on and so forth. So that's it for that. Now, what if we have fraction as the power? Let's look at that as number 5. So number 5. So what if we have fraction as the power? What do we do with that? So something like this, x raised to the power of a over b. So if we have x raised to the power of a over b, now whenever we have a fraction as the power, what we're simply going to do is that this, when we have a fraction as the power, the numerator of the fraction is the power of that number of the base, while the denominator of the fraction is the root of the base. So for example, so we have x raised to the power a over b. Now this means root of b root of x raised to the power of a. So the denominator is the root. So if the denominator is 2, it means square root of x raised to the power of, let's say the power is 3, raised to the power of 3. So that's it. So let's take an example. If we have 8 raised to the power of 2 over 3, now this is simply equal to third root of 8. I told you the denominator here is the root, while the numerator is the power. So it means we have third root of 8 and then raised to the power of 2 based on the law. And it's as easy as that. So what's the third root of 8? The third root of 8 is 2. How do we get 2? Third root means one number that when we multiply 3 times, we multiply the same number 3 times, it gives us 8. Just like square root is a number we multiply 2 times that gives us that particular number. That's the square root. So if for example, we're looking for the square root of 4. The square root of 4 is 2 because 2 times 2 is 4. But 8, 2 times 2 times 2 is 8. And that's why 2 is the cube root of 8. Now, since we have 2 there, for this power over here, we're going to make use of the power now because we're done with the roots. So for the power, 8 raised to the power of 2 is what? So we have to involve that here. So 2 raised to the power of 2 now gives us 4. So we've dealt with the base, the roots, and then the power gives us 4. Now take note, we need to deal with the root first before we move on to the power. So we're done with this, with the law 5. Now let's do, now what if we have, let's say x raised to the power of minus 1 over 2. Remember we've done the negative sign, we've done for fraction. So we said that the negative sign is the inverse. So if this is x, it means the inverse of x is 1 over x. That we've done that. Now when you have a fraction as a power, we've said that already. When you have a fraction as a power, just take the roots. So the denominator is the roots, while the numerator is the power. So but for this question, the numerator there is just 1. So the power is 1. While the root is 2, so we have the square root. So I don't need to write 2 over there because square root is still the original name is just square root. That's 2 roots. So except maybe from 3 roots and above, that's when I'll have to indicate third root, fourth root, fifth root. But once it's a square root, I don't need to indicate the 2 there because it's already general. It's already a general fact that it's a square. That's second root. Now let's make progress. So with these few laws, we can be able to solve problems based on indices. So as we make progress in the solutions we're going to be looking at, we would be referring to the laws we've talked about. And if we come across anyone that we need to add more laws, I will show us. So let's look at some few examples. We're going to be taking some few examples based on this topic. that we have done, and we're going to see how we can apply these laws of indices to solve problems. Now let's look at this question together. Example 1. So we have 125 raised to the power of minus 2 over 3, and this multiplies 15. So we have 125 raised to the power of 2 over 3 and raised to the power multiplied by 15. So we're going to be applying the laws of indices. Now we already established that when you have a negative sign as the power, we take the inverse of the number. So what's the inverse of 125? So the inverse is just 1 over 125. That's it for that. Now the next thing we'll consider is the fraction as the power. So it's not just negative as a power, it also has a fraction as a power. So, and we established that when we have a fraction as a power, the denominator of the fraction is the roots. So therefore means this will be roots. This will be the third root of 125, and then the numerator is the power raised to the power of 2. And then we have multiplied by 15. Now, what's the third root of 125? The third root of 125. So the third root of 125 is 5. Because 1 over 5, 1 over, because 5 times 5 times 5 is 125. 5 times 5 is 25. 25 times 5 is 125. So that's why it's the third root. 5 is the number that when you multiply it 3 times, you'll be getting 125. So that's the third root. Now let's take the root of that. So we have 1 over 5 raised to the power of 2. 5 raised to the power of 2 means 5 times 5, and that gives us 25. So we have 25 over there multiplied by 15. So 5 can go here 5 times, 5 can go here 3 times. So at the end of the day, we have 3 over 5 as a final answer. So that's it for that. That's it for this question. It's as simple as that. Now let's make progress. Let's do some more examples based on this we've discussed. So let's say example 2, we have example 2 we have, want to simplify 16 raised to the power of 1 over 2 times 8 raised to the power of minus 4 times 3 raised to the power of minus 2 over 3 divided by 81 raised to the power of minus 2 over 3. Alright, so here's the question. It's quite long, but it's easy as well. So here's the question we want to solve now. So let's just take them step by step and apply the laws of indices that we've looked at to solve these problems. Now, so for us to solve this now, let's look at this first part. We have 16 raised to the power 1 over 2. So there are several methods we could use to solve these problems, but let's see how. Let's apply the laws first. So we have square root of 16, 1 raised to the power of 2, because we established that the root, this is a fraction as the power. So the fraction of the power means square root of 16 multiplied by, so over here we have minus as the power, so it means 1 over 8 raised to the power of 4 times, over here we have cube root. So this we'll be getting 1 over cube root of 2 over 3. But we don't want to do that, because now if you notice, if we're going to take the cube root of 3, we would not be getting a particular answer. So there's no need to round that up to cube root, to write that up using the laws of indices. Now, well, let's look at 81 over there. So let's just write that down. So there will be no need to take the cube root of 3 to write it as a cube root of 3 raised to the power of 2, because we cannot actually find the cube root of 3. A 3 is not a perfect cube, so we cannot find the cube root. So we just let's leave it like that and see how we can change the next number. So we have 81 here. Now, when you're solving indices, one thing you should take note of is that whenever we're having problems, we want to make sure to make the bases the same. Going back to the previous law, which says when the bases are the same, if you have addition, if you have multiplication, you add the powers. And if you have addition, if you have division rather, you subtract the powers. So when we have problems on indices, what one thing we should aim at achieving is to make the base the same. So here we have 81. Is there a way we can make 81 3? So let's look at that together. So we know that taking 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So we have 3 times 3 times 3 times 3, 3 raised to the power 4. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So it means 3 raised to the power 4 is 81. Now, let's bring back the power we have there. So we have raised to the power minus 2 over 3. Of course, we're not going to throw that away. So, having said that, we can actually multiply the powers there, which will still be fine. So let's take the square root of this. If we take the square root of this, we'll be having 4 multiplied by 1 over 8 raised to the power of 4 times 3 raised to the power of minus 2 over 3 divided by, now this is 3 raised to the power of minus 8 over 3. Remember, okay, so there's a law that also states that when we have multiplication, when we have two powers, like probably one in the bracket and the other outside of the bracket, multiply both powers. Multiply both powers. So that's why we just multiply 4 times minus 2 gives us minus 8 and then over 3. So now notice we have the same base, 3 and 3 at the end. So that gives us a headway to solve these problems. Now, and there's something else you could notice here. From this 4 and 8, we can actually make this the same. So we can rewrite this as 2 raised to the power of 2 times 1 over 2 raised to the power of 3 and then 4 outside. So we can write it as 2 raised to the power of 3 times 4. Yeah, because 2 times 2 is 4, 4 times 2 is 8. So 2 raised to the power of 3 is 8. So these are allowed. We could actually do this when we're solving indices problems. Now let's make progress. So if we have this, let's recall the laws we listed. One of the second law, if we have a number like this and we have a division sign and their base are the same, of course their base are the same, 3 and 3, so we're going to subtract the powers based on the laws. So we have times 3, let's pick one of the base, 3, and then we have minus 2 over 3 minus, open a bracket, minus 8 over 3. All right, so from here we can say we still have 2 raised to the power of 2 times, so let's just break this down. So remember we said that when we see 1 over, that 1 over came from the negative power that we've had. So it means since the base here is 2, so we could still have 2 and then the negative power minus, so 3 times 4, 3 inside bracket times 4, the power, multiply the powers, so we have 12. So this gives us 12. Now multiplied by 3 raised to the power of minus 2 over 3, minus times minus outside of the bracket times minus inside of the bracket, that gives us plus 8 over 3. Now we have this, so we're almost done with this. So since we have the same base, notice we have the same base here as well, so we can rewrite this as 2 raised to the power of 2 plus, because based on the law we looked at, whenever we have multiplication sign we add the powers. So 2 plus, open the bracket, minus 12. Now multiplied by, so if we to do this, add these fractions together, so minus 2 plus 8 is minus 6. So we have is 6 rather, not minus 6, 6 over 3. So since we have 6 over 3 there, now here we have 2 plus minus 12. Now plus times minus is minus, so negative. So we have 2 raised to the power of And 2 plus minus 12 is minus 10. So we have minus 10 times 3 raised to the power of 2. So that's it. We are basically almost done. So we could just go ahead and simplify this. So we have 2 raised to the power of minus 10. I think we're almost done with this. So times 3 raised to the power of 2 is 9. Now let's write this in another form. So we know we can write this as 1 over 2 raised to the power of 10. So 2 raised to the power of 10 times 9. So here we'll be getting 2 raised to the power of 1 over 2 raised to the power of 10 times 9. So basically our answer is just 9 over 2 raised to the power of 10. Because there's nothing we can do here again, except we can just multiply. So that's it for this. Now we've come to the end of this class. In our next class, I'll be showing us how we can solve indices problems. So we're going to be picking WAEC questions, JAMB questions on indices, and solve every question on indices as simple and as clear as it should be. Please do well to follow this content, subscribe to our YouTube channel, and also like, and you can also share as well. Thank you. God bless you for watching. See you in the next video.